everyone, and welcome back to Mr. Anderson's Algebra 1 lessons. In this section, we're going to talk about graphing all things linear equations, everybody's favorite. So we're going to take a look at just graphing basic linear equation, and then we're going to take a look at graphing linear inequalities, and then we're going to
like so. There's my graph. Now notice, see the graphs look very different? That's because they have a positive slope here and a negative slope here. Easy peasy. Alright, last graph. Everybody's favorite, a fraction. Now you might not be able to see it very well, but that fraction is 3 over 4. Now that's actually a really good thing because I like counting slopes with fractions because it's a lot easier to see what the rise and the run are. Most people forget that you can put these little ones underneath them to do the rise over run. So just remember that little tip. So I got -6 here. I'm going to plot that on my y-axis. 1, 2, 3, 4, 5, 6. So that's right there. And I'm going to count up 3 over 4. Up 3 over 4. Up 3 over 4. So there's my points. And I'm just going to take my straight edge again and graph it out. Like so. There it is. Okay? So there's 3 easy examples on graphing linear equations. I know it seems a little tough this time of year, but you can do that. The next one I'd like to take a look at is graphing linear inequalities. So I got some linear inequalities down here, and you can see their little symbols. Let's zoom in here a little bit. Maybe I can. Let's do this. Haha. There you go.
Look at that. Perfect. Okay. Zoom in on that so you can see. So this one we got y is greater than or equal to 3 over 4x minus 6. So I took the same equation. I'm going to graph it the same way, but this time we got a linear inequality. So that means we're looking for a shaded region to tell us where our solutions to this equation are going to be. That's the real trick. So like normal, I'm going to graph it 1, 2, 3, 4, 5, 6. Up 3 over 4, up 3 over 4. Now, when you have linear inequalities, you have to take a look at, is your line dotted or solid? Well, whenever you have an equal sign underneath your greater than or less than, you have a solid line, because that means your solution to this equation can be included or on that line that goes through it. Now, if you notice from up here when we graphed, all of our equations had equal signs. So that means all of the solutions to these equations are on that line, not outside of it. Whoa, that was an epic failure right there, dudes. Alright, so here we go, back to action. So I'm going to have a solid line here. This one, I am going to have a dotted line. And that means the solution is not on the line. It's outside of the line. And this statement is only made true by points that are going to be less than this side. So that's what we need to look at. We'll talk about it when we get there. This is solid. Now, how do I figure out, how do I shade? Do I shade up? Do I shade down? Well, really what you need to do is you need to pick a point to plug into your equation to see if it makes it true. If it doesn't make it true, you shade away. If your coordinate point makes your statement true, you shade towards it. So I'm going to pick the point 0, 0 right here, and I'm going to plug that into my equation and see if it makes my statement true. If it doesn't, well, I'm out of luck. So let's see. I'm going to put my point right here, 0, 0, so I'm going to plug that into my equation. 0 is greater than or equal to 3 over 4 times 0 minus 6. And when I do that, adjust my paper here. When I do that, I'm going to have 0 over here, and I'm going to have greater than or equal to negative 6. So my question is 0 greater than or equal to negative 6? Well, the answer is it is greater than 6, so, or negative 6, excuse me. So that means I'm going to shade my points up here. So this is what my graph looks like, just like this. Okay, cool. So I'm going to do another one to show you guys what I mean with the shade, the dotted and solid lining. So this one's negative 1, so that's right there. My slope is 2, up 2 over 1, up 2 over 1. And this time I'm going to have a dotted line. My solution is not included into the equation. It's outside of it. So you can see how the line's dotted. And I'm going to pick a point that's a little bit bigger. I'm going to pick a point that's up here. I'm going to pick 2, 0. So 2 and 0. Or 0, 2, excuse me. 0, 2. Got to learn how to count my coordinate points here. I'm going to plug that into my equation. So 2 is less than 2 times 0 minus 1. 2 is less than negative 1, because 2 times 0 is 0. So this is what I end up with. 2 is less than negative 1. Is that a true statement? The answer is no. It is not true. So I'm going to shade away from my point, and that will look like this. Booyah! Last one. So can you guys tell me what the line's going to be? Is it going to be shaded or dotted? Is it going to be solid? If you said that line was going to be solid, you are correct. So let's get it going. Plus 3, the slope is 1, up 1 over 1, so it looks like this. I'm going to graph my line really quick, and it's going to be a solid line for me here today. And I'm going to pick the point 0, 0 again because that's the easiest. So I'm going to put in 0, 0. Okay. And that's going to be 0 is greater than or equal to 0 plus 3, which 0 is greater than or equal to 3. Is that a true statement? It is not a true statement. No, no, no. So I am going to shade up here away from my point. And there you go. Now, moving on to the last topic, which a lot of you are probably going to be having trouble with, and that is system of equations. System of equations with graphing. And I am going to graph these three guys right here. And with system of equations graphing, you're looking for where the two lines cross each other. That is the solution that makes these two true. And so what you're going to see, I'm going to have equations that are already in y equals mx plus b, so I just have to graph them and look for where they cross, and then I will hopefully have a really easy coordinate point that they cross at, so I can just label it for you. So this one's 2 plus, this one's plus 1, and this was up 2 over 1, up 2 over 1. There's my first guy right there. Okay. Next one is negative 2 and up 4. Negative 2. So negative 2, 1, 2, 3, 4 over 1. 1, 2, 3, 1, 2, 3, 4 over 1. Alright, so it looks like they're going to cross not on a lattice point. Great. So if I got this on a quiz, I'd be really mad at my teacher. But I would label the point right here, circle it. That is your solution. Now if you really wanted to figure out what it was, you just plug and chug and solve for the stuff here. But we don't have time for that. Let's move on to the next one. This guy's x. So I'm going to graph that one first. Starts at 0. Goes up 1 over 1, up 1 over 1, up 1 over 1. There's my first graph. My next graph is at plus 1. And I go down 3 over 2. Down 3 over 2. Those cross up here. So I know the dot looks like it's right there by 0, 0, but it is not at 0, 0. It's some other place in between. If you could really, really zoom in there like this, you can see that, hey, that is not at 0, 0. So you would really just kind of back out. You know, it would be, that's where it would be. That's the solution. I don't know how to label it, but that's where you would have right there, okay? Last and final graphs. Now take a look. These two have the same slope, so that could be a point to something that maybe these lines may be parallel, because parallel lines have the same slope, but I'm not really sure because I don't know the graphs just yet, so we'll see. Plus 2. Up 1 over 2, up 1 over 2, up 1 over 2. One second. Next one is going to be plus 3. So plus 3, up 1 over 2, up 1 over 2, up 1 over 2. Alright, look at that. We were correct. These two lines are parallel. They will never cross, so they don't have a solution. Again, I hope this has been a helpful, useful tutorial for you for graphing linear equations, graphing linear inequalities, and graphing a system of linear equations. Once again, thank you for viewing. Come back to me and see my other Algebra 1 lessons. This has been Mr. Anderson. Peace out.